Hello classmates, we are from group 6 and let's meet the group.
Let's get started. Now, what are elementary row operations? Elementary row operations is an important method to find the inverse of a matrix and to solve a system of linear equations through simplifying the matrix. ERO is also used to obtain an echelon matrix and reduce echelon matrix from a non-echelon matrix. There are three elementary operations. Number 1. Interchange the ith row or one of the rows with the jth row, another row of the matrix. This process is denoted as Ri to Rj. Number 2. Multiply the ith row of the matrix with the scalar k where k is not equals to 0. This process is denoted as Kri. Number 3. Add the ith row that is multiplied by the scalar k to the jth row, where k is not equals to 0. The purpose of this process is to change the elements in the jth row. If the matrix A is transformed to the matrix B by using ERO, then the matrix is called equivalent matrix to the matrix B and can be denoted as A is equivalent to B.
These are the properties to know which matrix are the REM or RREM. It has 5 properties to know the REM and 1 property to know whether it is RREM or not. Left to tell that RREM will be REM and not REM will not be RREM. So, the first property is that the matrix must contain at least one non-zero row, where the row contains at least one non-zero element, a number that does not equal to 0. As you can see here, in the first row, it has element 1 where it does not equal to 0. It can be 2, 3 or negative 1. Second property is that the leftmost non-zero element of each row is 1, where we call it as the leading one. It cannot be other than 1, like negative 1 or other real numbers. Third property is the element below the leading one are all zeros. Next, the fourth property is that the leading one of the lower row must lie further on the right of the leading one of the upper row. In the simplest ways, it shows the staircase pattern as in the example. Fifth property is, if there's any row of all zero, then they are placed at the bottom of the matrix as shown in example. Lastly, this one is to determine whether the matrix is RREM. So, the matrix must satisfy all the conditions in REM that I told you just now, and the column that has leading one must have 0 everywhere in the column to be considered as RREM. To have a better understanding, let's look at the example. The answer for example 1 is neither, because it does not satisfy the fourth property, where the leading one is not in the staircase pattern. The leading one in the second row should be in the second column to be considered as REM and RREM. Next example, the answer is REM but not RREM because it satisfies all the properties for REM but not the sixth property, which is for RREM, where the leading one in the third column does not have 0 everywhere in it. As you can see, 7 and 2 is at the top of leading one rather than zeros. Next, the answer for the third and fourth example is REM and RREM because it satisfies all the conditions. These two matrices have at least non-zero rows, then it has leftmost non-zero, which is leading one. Then the element below the leading one are all zeros. It also shows a staircase rule. Then the row that has all zero is placed at the bottom just like example 3.
Now we will go on to explain about the rank of matrix. The rank of a matrix is the number of row that is non-zero in that echelon matrix or reduced echelon matrix. The rank of matrix A is denoted with this symbol, which means rank of matrix A. Now, Let's try an example. Example, given matrix A, which is this matrix right over here, hence the rank of matrix A is equals to 2, since there are only 2 non-zero rows in matrix A, as we can see over here.
First question. Decide whether each of the following is a row echelon matrix REM, row reduced echelon matrix RREM, or neither. Solution question 1. Number 1. It is a neither, as it is not a REM and RREM. Since the leading one in each row, as the red color shown, is not following the staircase shape, hence it is not a REM, and from that we also can know that it is not a RREM, as one of the notation in REM had been rejected. From the above matrix, we can know that it does not follow the third condition of REM. Number 2, it is a REM but not a RREM. Why number 2 is REM? Because first, consists at least a non-zero row. Second, the leftmost non-zero entries in every row is 1, and we also call this the leading one. Third, the leading one in the lower occur farther to the right than the leading one in the upper row. While the notation for RREM is each column that contains a leading one has zeros everywhere else. From the above matrix, we can know that matrix does not follow the condition for RREM. Number 3, it is a REM and also a RREM. Since the matrix above follow all the conditions for REM and RREM, so it can be considered as a good example for REM and RREM. Question 2 is, what is the rank of a matrix for the below question? A, B, and C. Solution, rank of a matrix for A is 3 because there is 3 of the number of row that is non-zero in the above matrix. B, rank of a matrix for B is 3 because there is 3 of the number of rows that is non-zero in the above matrix. As you can see, the fourth row for B is all 0, and that's why it's not considered as rank of a matrix, and that's why rank of a matrix for B is 3. C, rank of a matrix for C is 2 because there is 2 of the number of rows that is non-zero in the above matrix. For the third row of C, you can see there's all 0, and that's why it's not considered as rank of a matrix, and that's why C, rank of a matrix for C is 2. Question 3 is, transform the matrix J 1, 2, 1, negative 1, negative 2, negative 2, negative 1, negative 1, 0 into the echelon matrix and reduce echelon matrix. Solution for question 3. Row 2 plus row 1. Row 2 is referred to row I, while row 1 is referred to row J. So we need to change the row 1 because it's referred to row J. Next, row 3 plus row 1. Row 3 is referred to row I, while row 1 is referred to row J. So we need to change the row 1. So we will get 1, 2, 1, 0, 0, negative 1, 0, 1, 1. Next, row 2 interchange with row 3. So we need to change the row 2 with the row 3 and row 3 to the row 2. So we will get 1, 2, 1, 0, 1, 1, 0, 0, negative 1. Next, negative row 3. So negative row 3 is referred to row J. So we need to change to negative row 3. So the actual matrix is 1, 2, 1, 0, 1, 1, 0, 0, 1. B, by continue from part A, row 1 minus 2, row 2. So row 1 is referred to row I, while negative 2, row 2 is referred to negative 2, row J. So we need to change that R2. So we will get 1, 0, negative 1, 0, 1, 1, 0, 0, 1. Next, R1 plus R3. R1 is referred to Ri while R3 is referred to Rj, so we need to change the R to R3, so we will get the reduced echelon matrix is 1 0 0 0 1 0 0 0 1. Question 4. Determine the matrix A 1 2 3 2 negative 3 2 3 1 negative 1 to echelon matrix, reduce echelon matrix and rank of a matrix A. Solution for question 4. So row 2 minus 2 row 1. Row 2 is referred to row I and row 1 is referred to row J. So we need to change at row 1. Next, row 3 minus 3 row 1. So row 3 is referred to row I and row 1 is referred to row J. So we need to change at row 1. So we will get 1 2 3 0 negative 7 negative 4 0 negative 5 10. Next, negative 1 over 5 row 3. So we will just negative 1 over 5 multiply with row 3 and we will get 1 2 3 0 negative 7 negative 4 0 1 2. Next, row 2 change with row 3. So we just change the row 2 to row 3 and row 3 to row 2. Next, row 3 plus 7 row 2. So row 3 is referred to I and row 2 is referred to J. So we need to change at row 2. Lastly, 1 over 10 row 3. We just 1 over 10 multiply with row 3. So the actual matrix is 1 2 3 0 1 2 0 0 1. Next, solution for reduced echelon matrix. By continue from part A, row 1 minus 2 row 2. Row 1 refer to I, negative 2 row 2 is referred to J, so we need to change at row 2. So we will get 1 0 negative 1 0 1 2 0 0 1. Next, row 1 plus row 3. Row 1 is referred to I, row 3 is referred to J, so we need to change at row 3 and then we will get 1 0 0 0 1 2 0 0 1. Next, row 3 minus 2 row 3. So we need to change to row 3 because it's referred to J and then we will get the reduced echelon matrix is 1 0 0 0 1 0 0 0 1. For the rank of a matrix is 3 because there is 3 of the number of rows that is non-zero in the above matrix. As you can see, the matrix all the row has number, so that's why the rank of a matrix is 3.
Conclusion. In conclusion, elementary row operations is an important method to find the inverse of a matrix and to solve the system of linear equations. It is essential to obtain an echelon matrix and reduce echelon matrix from a non-echelon matrix. However, the 3 elementary operations stated have to be always followed to perform a precise elementary row operations.
Thank you, and we hope you enjoy the video.